Welcome. This is a part of GPX tutorial series. I'm Priyata Kalra, Senior Scientist at Simulations Plus, and today I'm going to acquaint you to the PKPlus module for GPX, which is also an optional module. In today's tutorial, I'm going to walk through the Midazolam PKPlus tutorial project, which you will find in the tutorials folder of your GPX installation. Here, in this particular project, we have a 5 mg IV dose, as well as 7.5 mg, 15 mg, and 30 mg oral dose. We are going to use these information to understand the application of PKPlus in order to run a non-compartmental analysis as well as a compartmental analysis. Finally, I'm going to show you how to export the parameters which are obtained through these analyses in PKPlus to the pharmacokinetics panel of your simulation, and therefore be able to run the simulation with the desired result from these analyses. Let's dive in. You can see that I have selected the project of midazolam in my GPX. Before we enter the PKPlus module, I would like you to see the observed data. In the observed data, you can see that we have a 5 mg IV dose. We have clinical study of 7.5 mg, 15 mg, and 30 mg solution or oral dose. You will also be able to see at the end of the observed data, the dose amount being correctly described to the particular observed data, as well as the body mass in kilograms on which this observed data was measured. In order to run PKPlus analysis, we have to go to the modules of GastroPlus X window. Here, we can click on the PKPlus. As soon as we click on PKPlus, we enter the PKPlus analysis window. On top, you can see the compound. Here, you can actually toggle through the compound on which you would like to do the PKPlus analysis. You can see that it is midazolam for this particular exercise. In order to run the first analysis of PKPlus, we will do the exercise of importing the input of 5 mg IV dose, doing a compartmental and a non-compartmental fit on it, and then exporting the desired parameters to the simulation. Finally, run the simulation and understand how these exports are seen in different parts of the GPX panels. As you can see right now, our inputs are empty. In order to do the first run on the IV, we will go to the add and add the IV dose. So let's add 5 mg IV. When I write 5 mg IV, you can see that my exposure series, dose type, dose mg, infusion time, as well as body weight get populated with the values of different numbers. Please make sure that they are correctly associated to the input name that you are trying to represent in your PKPlus. In the exposure series, we right now are having the correct definition of 5 mg IV dose. There might be instances where the exposure series would not match the input name of your desired input. In order to access that, you just have to click on the exposure series. You will then be guided to the particular group name of the observed data as well as the series name. You can then click on the drop-down menu and toggle through the different choices of your group name or even your series name. In the dose type, we are right now having an association of an oral dose to an IV, which is not true. Let us click on it and correct it to intravenous. With this, we are actually ready to allow for our first run to be able to do the first simple non-compartmental and compartmental analysis on the IV dose. With this, we will go into the runs panel and define a new run. To do that, you will have to simply add new run. We can call this IV run. Once I call it IV run, In the inputs of the run, you can see the choice of 5 milligram IV, which we had input here on the input name. Please click on it and select it. You would know when you have selected it because it would turn green. Once it is selected, then we can go forward and look into the different model parameters that we can define for compartmental as well as the non-compartmental analysis. In the current scenario, we are not going to change any of these, but I'll show you in a bit how each of these can be impacted, especially when we are fitting both oral as well as intravenous doses. You can also see that we have elimination model type. There are linear as well as nonlinear elimination model type. The fraction unbound plasma is defaulted to 100%. Please make sure that you change it to the correct fraction unbound plasma, especially for hydrophilic drugs. In the Analysis tab, you can see the different compartmental models that are offered in the PKPlus module of GPX. In order to be able to run analysis for all of them, please click on the non-compartmental analysis model. Just drag with that click to the bottom, and that way you will be able to select all the compartmental analysis available to solve using the search method of PK Analytics custom limit in GPX PKPlus module. Once we have done this, we are going to click on the button Solve. You can see in the results panel the results of the different compartmental as well as the non-compartmental analysis. The first result that you see is of non-compartmental analysis. You can see that it has taken the 5 mg IV dose, and you can see all the calculation of non-compartmental analysis in this particular table. You can export the result of this analysis to your pharmacokinetics by toggling on the export button. You can also click on the particular cell or row of this table and copy it. Once you copy it, you'd be able to paste it in Excel to be able to see the results in the form of the table. Let's go on further. Let's come to the compartmental analysis. In the compartmental analysis, PKPlus directly returns the analysis for 1 compartment, 2 compartment, and 3 compartment. You can see the resulting rate constants for the different compartments being reported here. If we go to the end, we can see the Akaike criterion, as well as the Schwartz criterion, as well as the R-squared for the different compartmental analysis models. PKPlus directly picks up the model which has the lowest Akaike criterion. In this case, the 1 compartment model is already shown to be the best fit with the green toggle on. We can also see the clearance and volume distribution information, the weighted normalized clearance and volume distribution information. And finally, we can have a visual check of how our different models performed, which you can see here. In this case, we are also able to see the residuals. In order to remove the residuals from the observation, simply press the Control key and click on the residuals that you would not like to see. Now you can see that we have the observed data of 5 milligram IV, and we have the different compartmental models results being shown on the screen. Right now, all of them are in the same color. In order to change the color of some of these lines, you will have to select one of the prediction and then go into the plot options, select the plot options, and change the color in the plot options. I am not going to do this in the interest of time. Once we have seen through the different results that are given by PKPlus with regards to the non-compartmental analysis, as well as the compartmental analysis, let's try to now export the desired result into our simulation. To do that, please look into the export toggle button here on the desired analysis. As PKPlus has reported 1 compartment model as the best fit, we are going to simply export this model. In order to do so, toggle on the export button. Once you have toggled on the export button, please go to the end of the screen and choose the simulation in which you would like this result to be exported. Here we have a 5 mg IV simulation to which we would like to export the result. We can now click on the export result button, and as soon as we do so, we are thrown messages in the form of information where it says that compartmental PK parameters have been exported to the pharmacokinetic panel. It also reports that simplified absorption settings and first pass extraction have been exported to the selected simulation. In this case, we do not have a simplified absorption model set up. Therefore, we will not be able to see this. However, in the tutorial series, you would be shown how to allow for a simplified absorption model, and you can therefore use that tutorial information to allow for a simplified absorption result to be exported from PKPlus into your simulation. In order to see the PKPlus exported results, we have to go to the pharmacokinetics panel. Once we go there, you can actually see in the compartmental model, now we have two rows defining the model name. First, the human one compartment model, which was predefined, is already existing. And then the IV run one compartment model, which was actually fitted by us in this exercise. Let us delete the human one compartment model. We will do so by pressing the Control key and clicking on the particular row. Once we do that, the whole row gets selected by being green. Then we can click on the button Delete and delete this particular model. Now we only have the IV, the run that we had exported from PKPlus, which is a one compartmental model. Let us now go to the simulations, and in the 5mg IV simulation, how to understand and identify whether our compartmental model from the PKPlus is associated to this particular simulation. To do that, you will go to the compound settings. As soon as you go to the compound setting, you can actually see in the compartmental model name, the current compartmental model name is the IV run one compartment model. With this, you can be sure that you can check the warnings and then run the simulation as you have the right compartmental model analysis exported from PKPlus associated to your simulation. Once we run the simulation, we are able to see that we have the fit of the IV dose, observed data, as well as the IV dose simulation here. But you are able to see there are some dots, or the line doesn't seem straight. The reason why this is so is because in the configuration, right now, we have an output frequency of every 10 steps. Let us change that output frequency to 2 steps and then run the simulation. Now you'd be able to see our simulation is much more smoother as compared to the previous simulation. Let's go back again to PKPlus, and this time try to do a compartmental analysis as well as a non-compartmental analysis for not only IV but also PO doses. In this case, we are going to add the different PO doses. So let's add 7.5 mg solution. When I write the 7.5 mg solution, as I said previously, the exposure series, the right exposure series is not depicted here. Therefore, I'm going to choose the right exposure series. The dose type is oral, and because in the observed data, my dose as well as body weight was defined, it is right now correctly associated. Let's add 15 mg solution. Again, let us associate the right solution series to the dose. Finally, let's add 30 mg solution series. In this one, you can see that everything on the dose as well as the body weight is 0. That is because in the observed data, I have not entered that information. So what I can do is I can define it directly here, and I can edit these columns of the table to add the desired information. Once I've done that, let us, for the hygiene of the different runs that we have defined, add a new run. And let's call this IV and PO analysis. Once I have defined the IV and PO analysis, again, on my inputs, I do not see any selection. In order to select all of them, long press your right click of the mouse button and scroll it downwards. This way, you'll be able to select all the inputs. Because we are using oral dose, let us also fit the F% for the oral dose. This is midazolam and therefore is quite highly bound. And therefore, we are going to use the unbound percent of 4.4 in this particular analysis. Finally, we are going to choose all the different compartmental as well as non-compartmental analysis to be solved by PKPlus. And we are going to click on Solve. Once we solve this, in the results, you can now see the non-compartmental analysis result for all the different dose types associated in the current run. You can also see in the compartmental analysis, the PK Analytics Niedler-made model reports two-compartment model to be the best fit. In here, we can also see that the F% or the bioavailability is around 28%, which is very close to the general clearance that has been reported for midazolam. Looking at the visuals of all the fits, we can now deselect all the residuals to have a better idea of how good the fits look like. To do that, press Ctrl and then deselect the residuals for each compartment. We can now see with different colors the different data as well as the different compartment fits for all the data. With this, you can actually play around more and therefore, at the end, pick up the desired compartmental analysis result, toggle it on, and export it to your desired simulation as I showed you for the 5mg IV simulation. Thank you very much for paying attention. Have a good day.